Jensen, we are ready and we are live. Hello, everyone. Very good morning. This is so funny, Jensen. Very good morning to our webinars, to our gas sampling webinars. At this time, Jensen, I have to put you on the solo layout because this is really kind of funny.
Oh dear.
Very serious. Jensen, very good morning. This time not from, where are you?
From Bangkok. It's 3 o'clock in the afternoon from Bangkok, Thailand.
Oh, all right. That's good. But where exactly in Bangkok are you right now?
Oh, this is the biggest exhibition center. They call it BITEC Exhibition Conference and Event or Trade Event Hall.
Wow. Okay.
Yeah,
So,
yeah. So
yeah. Sorry.
So today's this event that I'm visiting right now. In fact, is the oil and gas, all right, the petroleums, and we have also the power. Yeah, the power, learning about power plants as well as the marine industry, right?
Wow.
So it comes from the instrumentations, the light, and as well as the heavy equipment.
Oh, right. Okay. Okay. But also the analytical part and also the CEMS part, the
Yeah,
emission monitoring.
yeah, yeah. But
Great.
most of them are the gas detectors, sampling system as well.
Right. Okay.
Yeah. So our one of the partners, they are putting up the show here.
Yeah. Super. But that's great and good to hear. I think yeah, we're very proud of our partners in Thailand and in the region. And yeah, so is the show busy or not so busy, Jameson?
Oh, I would say this is the second day.
Okay.
I would say we have a pretty is everybody taking this chance to travel and then
Right.
getting to know each other again. You'll be very surprised that it's as good as the before the pandemic.
Yeah. Yeah, I think the same when you see ADIPEC in I think in the Middle East, also very big response there, and yeah, but it's good. Shows come back, and also yeah, the travel is back, and also seeing each other in person again is back.
Mhm.
Very good. But Jemson, I think then you will be spreading the news or our solutions also in this show, and therefore I'm very happy for this webinar which we have today. So that really gives us the chance again to focus more on the very special heated sample lines. I think with very special, we are not in everyone who follows us or who knows about our product strategy. We have the basic, the plus, and the process product lines. And today we're not talking about the basic products, but more about the specialities, which are very relevant. And Jamison, I don't know, what is your feeling regarding safety? Is that still one of the major topics, or what is your impression?
In fact, two of the most, I think, three areas that are putting a lot of emphasis nowadays. Yeah, you know, as I know, energy, yeah,
Right.
safety, as well as environment.
Okay.
Yeah, so the whole exhibitions now, there are actually ongoing speakers all about energies as well as environment. Thailand, for example, they are with regulations. They started that the measurement of emission.
Right.
Not only that they are measuring the threshold limit, they are measuring the volumetric, the mass concentration that includes the flow meter, the mass flow meter, the temperature, right, to capture the velocity. They measure the whole volume of how much really the emission, as
Right.
well as the stack, the flare stacks. The flare stacks is already not only in Thailand. In fact, the whole ASEAN, the flare stacks, they're also pollution.
Yeah.
How much they are throwing out. Yeah. Huge environmental.
Yeah, I think it's great to hear because luckily we have some solutions for this
Very big coincidence.
For this situation. Yeah, that's a coincidence. Okay, yeah, but first of all, I think we have to speed up a little bit because we put some effort in this webinar today. Yeah, first of all, Tobias is the community manager today. I'm sitting here with Jonas. Great to have him. I mean, you saw him in the last webinar already. But today he has even a more, let's say, active part in this, because today really we will show something new and we will explain something new, and therefore I'm very happy that so many people again signed up and are watching us and are following us. By the way, I mean, Jemson, we have you on the line, and it's super nice to see. There is the good morning from Brazil message. Antonio, very good morning or good night, or within the middle of it. Really means a lot to us that you get up that early. And I think the person who's currently in the middle of the day is our dear representative and colleague in the Middle East, Jose Luis. Good afternoon to you, and very good greetings in this intense region. So yeah, great to hear that the world, the small PSG world, is present. And yeah, let's get started. Very short, I would like to draw the attention on our next webinar, which will be at the 17th of November, in 2 weeks' time. Another challenge, because to cover in 30 minutes the sample gas cooler topic will be tough, but
it's challenging.
Yeah, but I would say challenge accepted. I think we can pretty good make it. Okay. So, but let's not lose too much time, and let's focus on the topic here today. We already touched this a little bit in the last webinar, where we have been started to discuss the probe tubes inside the heated sample lines. And when we have a look at our prepared example here, I think everyone knows. And Jameson, I think that was something which really came from you at that time. You said the heated sample line, even in a sampling system, very often represents the biggest surface inside the system, right?
Well, all this, I think we have to compliment Tobias behind the backstage.
Right. Yeah. Yeah. No, but I think also from the meaning and from the importance of the heated sample line, of the probe tube, which is really responsible to transport the probe. The probe tube itself represents the biggest surface, and therefore it can also have a very big impact, right? Yeah.
This is we always use the word, it is the most underestimated. Many people see this as the black holes without realizing that it has contributed to the biggest surface area during the whole sampling, the whole sampling journey.
Yeah. Right, but I think after this webinar, no one will say that ever again, because everyone will understand how important this product is. Okay, no, but let's have a look. I think we already gave an overview, James, and I would say in most of the applications in CEMS, we mainly talk about PTFE and PFA, right? This is, let's say, the standard choice of materials. But also, this is something we already mentioned in the last webinar. We have a long list of different materials which are applicable or available inside of our heated sample lines. I think the latest number is that we have more than 5,000 configurations in our system. So quite a lot. And I think next to the material itself, the surface, and maybe also the coating or which is on the surface, is quite relevant. So as you can see here, we also offer many varieties or many solutions if, for example, the surface will be electropolished. The electropolishing of the stainless steel in endless dimension is done in order to flatten the curves inside the tube and in order to smoothen the surface roughness. And I think we had our own webinar just to compare what kind of technologies are available for this. And out of this webinar, we had, I must say this here again, this is not made by me or by us, this is made by Benedikt Henkel from the company Henkel, which logo you can see here. And this is a comparison between silconert covering, meaning a coating of the inside of the tube, and not against, but because at the end it is also possible to combine these two technologies, which means you can have an electropolished inside and coating in additional. And so I would say this is really a very good overview and a very good slide, which gives the end user the right choice, to decide whatever technology is the best for him. Jemsen, do you have any special comments on this, or
well, I think the
opinion, or is this mainly?
Yeah, especially for the petrochemicals. Yeah, the special electroplating. All right, the amount of pits is on the stainless steel. They have to consider why we call it the analytical sample line. Many people didn't realize that many of the lines that are available in the market, unlike the one that we are emphasizing on the word analytical, where we have taken into considerations about the stainless steel, the amount of pips, that means the amount of hole, a small porosity within the stainless steel that can trap the gases that will cause memories, right?
Yeah.
The silconert coating for certain sticky gases. These are the areas that we like to, one of these days, any of them who has inquiry, we are most welcome to come to ours for advice.
Yeah, I think that's a very good point, Jemsen, what you just said, memory effects. And I mean, the nice development for us and our solutions is that the measurement ranges go always lower. So, and when you measure not only ppm, parts per million, but also ppb or PPT, or you go higher than that. I think any memory effects and any losses inside, and this is also what we learned of this big surface, affects at the end really the analytical result and the measurement. So very important that we can support you in the right selection of your application, because there are many reasons for this. Also, sometimes we had installations where we had so aggressive and high flow inside that with adding a coating into the heated sample line, this allowed to extend the time of operation. So also this is something we would like to outline here. Okay, now, because I know this topic will take quite some time and we did some preparation, let's talk about ATEX. And I'm pretty sure we will do another ATEX webinar just about ATEX heated sample lines and the new changes and the upcoming, what means upcoming, I think it is already there, but this is the big innovation and this is the big discussion in the industry. I mean, Jonas is relatively new to this industry, but I think already from the first discussion, it's interesting to see the development between the traditional lines and this new technology. Or what do you think?
Absolutely, you will have a lot of touching points with ATEX technology as a whole. With ATEX systems, it becomes more and more relevant by the day. So really, we have also really interesting solutions to offer you, and really innovative solutions.
And this time we also prepared something to make this even more, Jemison, I mean, sometimes I have the feeling that, showing this to the customer is, what does it mean? Not so convincing, but people do not fully maybe understand the new the new development here.
I mean, we can tell you a lot, but today we will prove it.
So
Yeah.
we were thinking, Jemison, and maybe, I mean, you remember when we do this comparison, what is the new development in the ATEX Heated Sample Lines? So I created this slide here, which in the past, the only thing we were looking at was the heater, the tracer itself. Yeah. So everyone was just focusing on the heater, and I think this is also a well-established and common technology that everyone understood. Okay, if there is a flow inside of the line in the process or the probe tube, there is energy. So there's something we need to do about this. So I would say this is state-of-the-art technology since 20 plus years. To have a conductive grounding of the inside tube. This is, like I said, state-of-the-art technology. But nowadays, the relevancy or the requirements, today's requirements for these, even for this type of equipment, even if it's installed in cable trays and not, let's say, it's not moving a lot, the requirements have changed because now there's a look into the entire component, the entire solution. And this is the reason why I marked this here. So we're not only looking at the heating cable, we are also looking at the jacket itself. And I was thinking a lot, Jemison, what is the best way to alert the people or to make the people understand why is this so relevant? And I think we have not shared the slides before, James, but what do you think? I always think a junction box is a good example, or don't you think?
Mm-hmm. I think, in my opinion, is that on the in terms of static, you can show them a lot of examples, like the PowerPoints, and give it illustration. However, I think a live demonstration would be one of the best convincing for the end user to see with their true eyes, what really we are really referring to.
Yeah, that's true. But I also try to, to explain the people, the engineers who make the decision what equipment is to be used. If here we compared two pictures. There is one junction box, and you see, let's say the dimension is comparable. And you see the junction box, there's one junction box for the safe area and one junction box for the ATEX area. And I mean, okay, there's also some difference in this, I don't even know the English name of this cable inlet,
cable
glands, whatever. There might be, or there for sure is also some difference, but the main difference is the conductivity of this material. And this is something we would like to show. When I just took a picture of an analyzer container, which was produced here in our factory. And I just took a picture, showing, okay, there's a couple of junction boxes. And you also see the cable trays. So it's clear this is an ATEX classified area. So it's clear that all components have to be ATEX approved. All cables, the normal power cables, are grounded here in the cable tray. And there's also a huge difference when we have this discussion, because sometimes people say, but standard electrical cables are not conductive. Where is the point? I mean, the point is the difference in the architecture.
Yes.
If you look at the standard cable and you would have a dimension like this, then underneath you have copper, and there is and we have insulation material, so the potential which can
build up.
Yeah, which can build up due to wind, due to cleaning, due to someone passes by, is a big difference between a heated sample line and a standard electrical cable, even if the dimension is the same. So, and this is something now, if this goes right here, I think it will, let me push the right button, Jemsen. Now, we would like to prove it.
Yes.
So, what we prepared, Jonas, maybe you can show this.
Yes.
This is a standard junction box.
Exactly. This is one of our standard junction boxes. So every engineer would know if there's an ATEX certified area, he wouldn't use this one, and we will show you why. So we prepared a little measurement instrument over here, and if I just touch the surface with the meter, you see that there's sorry,
there's some cable chaos.
Yes. That there's no really change in the conductivity. So you would see, we'll show you in a second, that if there's a difference in the resistance, you would see a huge peak in our resistance meter, conductivity meter. So let us prove it to you. This one would be an ATEX certified box. So every engineer would know just from everyday experience that if it's an ATEX certified area, or if it's an ATEX relevant area, you would of course use this one, because if we touch it over here, you see, let me show you, I don't touch it, I touch it, I don't touch it, I touch it. So you can see that there's the conductivity on the surface, or even at the whole system. And of course, if everybody knows just from their experience to use like this one for electricity, the same normally has to go even also for our heated sample lines. But this is a thing not a lot of people have in mind. So this is why we prepared this little test today, just to show you and to bring you in mind that also the surface of our heated lines are the same material or have the same properties like the ones at the ATEX certified junction boxes.
Okay,
for example.
Jonas, maybe slowly. Yeah, we start with the traditional or the standard model. So this is how we call this PSG extruded AX. This is the traditional way. We have an ATEX certified heating cable. By the way, we have the same heating cable here from Raychem in all of these installations. And here you will see, Jonas, if you can start your measurement. So Jonas is testing the conductivity, and there is none. There's no conductivity. So which means in this traditional way, and don't get us wrong, I mean, we don't want to panic or something, but we would like to explain. If this type of heated sample line is grounded everywhere, I think, I mean, there is no issue, there is no problem. But if we remember the installation, which we just saw in the analyzer container, it's very hard to ensure that everywhere this is on the cable tray grounded.
And we're meaning really everywhere. So like there's don't have to be more than like 2 quadruple centimeters that don't have protective earth underneath it. So it is much more easy to get this conductivity with one of our conductive auto jackets.
Yeah, and this is what we would like to show here. So Jonas is now, I think you can see in the background, even if he touches the cap, there is the conductivity. And and this is the importance of the entire system. So we see that we have the high conductivity at the jacket, and this at the end then really allows us to make sure that when you install this special line, that we can offer the full ATEX certification, or I said we are currently working on the IECX certification, which at the end will allow you to have really a safe operation
everywhere in the world.
Of this equipment. Wow. Okay, Jensen, what's the explanation? What do you think? Was this good to understand, or Jensen, are you still there? Okay, maybe he has some problems with his at the booth at the moment. Yeah, but again, like we showed, there is the AX, the extruded product with ATEX, AX2 and AX3, and this at the end comes including all the caps and all other equipment. Jemsen, are you back? Are you back, Jemsen, or is still something wrong? Okay, anyway, yeah, but I think that's we also give an overview that at the end there comes the full examination, the full certification of this, the conductive jacket, the conductive shrinking sleeves, which are used here, and this is all what is displayed and shown. Okay, so last one. Wow, I think we are going very fast here, but I think we can make it on time. 3 minutes left. Hybrid. We painted a picture here of a typical PNID of a CEMS system with all the components I think we shared for many times already, which is the gas sampling probe. We have the heated sample line, and then whenever it's a cold extractive system. But in this case, the main topic we want to discuss here, the so-called hybrid heated sample line. It doesn't matter if it's a cold or a hot wet system, cold dry or hot wet system. We would like to focus here on all the infrastructure and options you need to install whenever you have a probe and you want to operate a probe. Which means there can be multiple things like, for example, the probe needs a power supply. The probe might need a temperature controller, depending on the controlling technology. I mean, we also have self-regulated solutions. A probe might also need a signal for steering the blowback.
The back purging.
Yeah, the back purging, the blowback. And and this is, let's say, the innovation of our concept. So far, all of this is installed closed by the probe. And I mean, maybe also there, Jemsen, you have a long experience of many probe installations, and you know how difficult sometimes the areas are where the probe installation have to take place. And our concept with the hybrid heated line is the following. We will bring the entire, let's say, supply which is needed to operate the probe within one heated line, within one bundle. And this, as you can see here in the picture, can even include the back purging, which we will preheat inside of the hybrid heated sample line, the power signal, and again, I would think the hybrid concept is we can offer a lot of individualization there. And at the end, it allows the operator to do the main control and the main operation from the shelter and not in the field. I think this is the main difference.
It all is enclosed by the extruded line, so there can be no water or something dripping into it. So you don't have any problems with the insulation like outside or even in rough environments.
Yeah, that's another big advantage. You're right. And we have two heating areas inside of this hybrid line. So we will have the hot area, which is 180, 200 degrees. And then we have the outside area, and still there will be a heating of roughly 100 degrees C. So even the instrument air will be preheated. So everyone knows, who's currently knows about the challenges in the installation, and then this really helps, to supply everything you need just by the hybrid cable. Anything we have forgotten, Jemson? Are you still with us? Can you hear us, Jemson? Because we cannot hear you.
Jemson, blink if you're in danger.
Yeah. you are muted somehow. Okay, you can still hear us. Okay, you are muted, but anyhow, okay. Wow. Again, as I said, a big challenge. I think, there's some mistakes we already outlined so far. And but I think we made the point, and we were able to cover or to show the relevancy here, especially because we believe that safety is one of the most important measures, and supporting the industry with this very safe technology is something which really matters to us. With this, we would like to end this session now. I want to thank everyone for your support, for your help. Jemson, have a good show. Yeah. I think you can still hear us. Okay, at least you can still hear us. We cannot hear you. But we wish you a great time in Thailand, a lot of success, and thank you everyone for following us.
Thank you everybody
for joining this session. Yeah.
Bye.
Thank
See you in 2
Bye-bye.
weeks. Bye.